What's going on, you guys, and welcome to the channel. In this video, we're going to be looking at object-oriented Python. Now, for those of you who are beginners, then this video should hopefully be the perfect one for you who want to transition from being a beginner Python programmer to a more intermediate one. For those of you who just want a recap on object-oriented Python, then again, hopefully this video should also add value to you as well. Now, unlike my other videos, I will not be making use of PyCharm or VS Code. I will instead be using Replit, which is an in-browser IDE, and all the code that will be written here will be in a link in the description below, so you guys can definitely go ahead and check that out. But without further ado, let's explore the wonderful world of object-oriented Python. Now, before we actually get started, we first need to understand the concept of what an object is. Now, I'm going to go ahead and assume that for those of you who have landed on this video and are following along, then you've written Python before. And with that in mind, you've actually been using objects and classes without actually being aware of it, unless you have been aware. Okay, so first, let's go ahead and create some very basic variables. We'll say a equals 1. We'll create a string as well, b equals what's up, and we'll say c equals a list, which we'll just add a few numbers in. Okay, now as a kind of a spoiler, all of these are actually objects. So this one is an object of an integer, this is an object of string, and this is an object of the class list. Now we can go ahead and actually see that. So we can say print type and then a print type of b, and we'll say print type of c. Now let's go ahead and run this. And over here in the right side, you can see that a is a object integer of class int. The b is, so what's up, is of type string, so it's from this class string, and c is of class list. Okay, so these are all classes, and if you've been using these very primitive data types, then you've actually been using classes, because everything in Python is actually a class or is an object. Now, an object is an instance of a class. So just like one is this thing here, this a is an object. It's of the class integer or int. B is of the class string. This is an object as well. C is of the class list, which is an object too. So everything in Python is an object. The same also goes for functions. So we can say some function, and this will just say print hello. And if I go ahead and say print type some function without the function call, so without the brackets there, and I run this, now we see here that that is of class function. So actually a function is an object, just like everything else in Python. Okay, so let's actually go ahead and remove all of this and start with our kind of example. Now, classes become very useful when you want to kind of conceptualize something, something rather complex, something a bit more complex than like an integer or a list or a dictionary, and that's where classes can become very helpful. Now, let's go ahead and create a dictionary that will represent a school. Now, for those of you who have followed a few of my videos before, then you'll know that I'm a big Harry Potter fan. So let's go ahead and name this school. We'll say name is Hogwarts. This school will also have students. This will be a list of students. So we'll say Harry Potter. We'll have Draco Malfoy. And for those of you who aren't Harry Potter fans, please bear with me. These are just, names, treat them as that. We'll also have Luna Lovegood. And let's leave it at that for now. So we have this school, it has a name, which is Hogwarts, it has students. It also has courses. So we'll say the first one will be potions. That could be one course. Another could be magical history. We can also add, let's say, magical creatures. Okay, so we have some courses as well. And let's say we want the country, we want to store the country of this school. And this will just be United Kingdom. Okay, so we have our kind of dictionary which represents a school. We can go ahead and do stuff with that now. We can say school. And let's say we want to add more students. So we can say school and then students. And then we can say append. And let's add Neville Longbottom. Okay, so we can actually go ahead now and print out school. Hit run, and here on the right side, you'll see our dictionary. Let me just shrink this here. So we have our name, we have our students, we have courses, and we've added Neville Longbottom to our list of students, and we have the country. So all of this, of course, is valid code. It runs, it can, everything's working fine without any complaints. But the kind of representation of the school is rather ugly. I mean, we have to, in order to add students to it, we have to kind of use, we have to make our key reference here with students as a string, which is a red flag because, you know, there could be a typo in here and, you know, nothing would warn us about it until we actually run the code and then we append it here. So again, yeah, nothing too great. And this is where a class can be of great use. So let's go ahead and move this school into a class. So I'm going to go ahead and say, I'm just going to remove this here, keep the dictionary as a reference for now, and say class school. So you need this keyword class here, and then the name of your class, and this is school. Inside that, I'm going to say the name is Hogwarts. The students, and I'm just going to go ahead and copy this here. Then I'm going to say the courses, copy that, put that in, and the country. And we'll say United Kingdom. Now already we have a better representation than this dictionary here. So what we can do is, in order to use this, we can say print, and in order to get the name, we can say school, and then we need brackets like that, and then say name. Now if I run this, we get Hogwarts. I can do the same with school here, and say students. Run this as well. And yeah, we actually don't need these brackets, sorry. But we get a better representation of this school, and we can access like the students without having to do the whole, you know, square brackets and then students like that. It's much more safer to just do students like so. Okay, so this is good, but it's not perfect. We can also create like we can store this inside a object. So now Hogwarts here is going to be our object, and we'll say school like that. And we can do the exact same thing and say print Hogwarts, and then say, I don't know, courses, run this, and we get potions, magical history, and magical creatures. Okay, but let's say we want to create another school now. So let's say we want a, I don't know, sports school. And we'll say school like that again. Oops, school. Now, if I say print and then sports school dot name, run this, I get Hogwarts, which doesn't really make sense. I mean, we can go ahead and change it. We can say sports school dot name equals, and we'll just say sports school. Now, if I run this, we get sports school. If I run print Hogwarts dot name from both of them. Hogwarts still remains. We're not actually changing Hogwarts itself. We're changing just the value of name for this sports school. But okay, this again, yeah, it's nice. But it like we're looking at it, we're seeing a lot of kind of hard coded stuff. We can of course keep name to like a blank one and then change it as we go along, but it's not nice. So what can we do to kind of fix this? So one thing is, let's actually just go ahead and remove all of this. You can comment it out if you want as a reference point. And I'm going to delete this as well. So actually, let me just bring this back. And bring this back before deleting it. So you can just see that this name, upon initializing, it was set to Hogwarts. So when we created our Hogwarts school object, so Hogwarts being the object, school being the class call, we're creating this object, storing it inside Hogwarts. So when we created that, when we initialize that, we set the name to Hogwarts. We set the students to this list here. We set courses to this list here, and the country to United Kingdom. The same also goes for sports school. When we created this, the name was initialized to Hogwarts, and the keyword here being initialized, students set to this, etc. Now, with this initialized word in mind, let's go ahead and change our school class. So let's say define underscore init and then self like so. And let's just put pass here for now. So what's actually just happened? So this init represents the word initialize. And when we create a school now, we can say school equals school like so, just like that. And it works fine. Let's just call this Hogwarts. Okay. And what this initialize does is it sets everything up upon initializing our object. So we can now say inside that, we can say name, we can say country, and let's leave out courses and students for later on. Okay, so let's go ahead and run this, and we should actually expect an error because over here in the right side, we see type error, init missing 2 required positional arguments, name and country. Let me just expand that. So name and country. Okay, so let's actually fix that. So in order to do that, we can say name being Hogwarts and the country being United Kingdom. And in order to just be extra clear, I'm going to add some named arguments. So I'm going to say name equals Hogwarts. Before that, it was perfectly valid, but just for readability, country equals United Kingdom. Now, if I run this again, there's no output, but everything has run correctly. Now, if I print Hogwarts, I run this, we get the address in memory, which is this here, and we get this like main school, which is telling us that this is a of the class school. But now if I add .name, run this, we get back an error, school has no attribute name. And that's because all we're doing right now is we're passing in this name here and we're doing nothing with it. We're not setting it to an attribute as this error is stating. So how do we create an attribute? To do that, all we have to do is say inside our school class, say self dot, and then you can give it whatever name you want. I'm going to actually just say name, and I'm going to set it to the name that we passed in here. So this, that. The same goes for country, so self.country equals country. Now I can go ahead, I'm just going to get rid of this pass statement there, run. And now I get name, which is Hogwarts. Now, just to be extra clear, you can name this whatever you want. I can name this some name. And then if I run this, I will get an error because name has no attribute name, which I'm calling here on line 19. I would actually have to say some name, and then it works. So that's, yeah, just to kind of, it can be a bit confusing if I'm naming both the attribute, which is this self.name, with the argument that we pass in, but name makes more sense. Okay, so that's our initializer. So when we create our Hogwarts object, we're saying the name is going to be initialized to Hogwarts and the country is going to be initialized to United Kingdom. Now we also want room for our students and for our courses. So for that, I'm just going to go ahead and say self.students is going to be initialized. So this attribute students is going to be initialized to an empty list. So square brackets, and self.country, or not country, sorry, courses is going to be a list as well. And now with that, we can go ahead and say print Hogwarts dot students, and I can run this, and we get here empty square brackets symbolizing that it's a list but with just no elements inside it. I can also append it by saying Hogwarts dot students dot append, and then add in, say, Harry Potter. And if I run this now, I get Harry Potter. Okay, so that's our initializer. We can also add some functions, or they look like functions, and we'll get to this self part in a second, but they're actually called methods in this case. So any function, quote unquote, that you write inside of a class is actually a method. That's the naming difference. It's more semantics there. But let's add a function, add a method called add course, and we have to have the self here, and we need the course there. So this is just an argument, and what this will do is we'll say self.courses.append and then course. Okay, so what is this self doing here? Self is actually referring to the instance that is calling it. So if I just, let me just remove this there. If I create another school object, let's say this is a sports school, and we'll just say school, say name equals sports school, and we'll say country equals, I don't know, say Iceland. Okay, so if I now say Hogwarts dot add course, and then add in, let's say, potions, and then say sports school dot add course, and throw in, let's say, basketball. What's happening is, first of all, you can see that we're missing out this self argument here. Like even when we do our init, there's nothing where we're saying self equals, I don't know, 1 or whatever. That's because self is actually referring to the instance itself or the object itself. So here, this add course with this self, we're saying, okay, self, in this case, when we say Hogwarts.add course, we're saying Hogwarts being self, add course to the object that's calling it. So Hogwarts, sorry, that. And then with sports school, we're saying, okay, for sports school being self, add course basketball to sports school. Now, if we go ahead and print this out, so we'll say Hogwarts, and then we'll say Hogwarts dot courses. I'm just going to copy this, paste it below, and say sports school, and then just here sports school. If I run this now, over here on the right side, you'll see potions. When we did add course, we did potions, add that to our Hogwarts object. So call it on our Hogwarts object. With sports school, we're saying call add course on our sports school. So that's why this self is important here. Okay, hopefully that was clear for you. If not, yeah, please rewind that. And also a bit of experimentation and a bit of Googling may help as well if you're struggling with this self concept. But hopefully my kind of explanation helped, but we can go over it again in a second. All right, so that's our add course. So we've added our potions to Hogwarts. We've added our basketball to our school. Now we can also add another method. We'll say enroll student, and again we need self, and we need the student. So we'll say self, so get the attribute students and append student to it. Now we can say Hogwarts dot enroll student, say Harry Potter, and we'll say, let's add another student, Hogwarts dot enroll student, we'll say Draco Malfoy. Now let's go ahead and print out Hogwarts students, and we'll say Hogwarts dot students. Run this. Over here you get Hogwarts students, Harry Potter and Draco Malfoy. And that's because with this self, we're saying for Hogwarts, call this enroll student on that object Hogwarts and pass in the argument Harry Potter. Now if we jump into enroll student, it gets this student, it refers to the students list that we initialized our object with, adds that student to it, and the same also goes for when we call it on Draco Malfoy. Okay, so that's really it with the basics of a class. So we have these methods that we've defined in it where we can add a course to our school, we can enroll a student to our school, but this student that we've defined, Harry Potter or Draco Malfoy, is just a plain string. What if, and to be honest, in an actual system, a student would be a lot more complicated than just a string. It would carry a bit more information. So let's actually just get rid of this here. And I'm actually just going to delete this add course. Let's go ahead and create a new class. And this class is going to represent a student. Now we'll say here, class student. We'll do our init. So init here, so our initializer. Our student will have a first name, and it will also have a last name. And we'll say self.firstname equals first name as our attributes. Self.lastname equals last name. Okay, so let's go ahead and create a couple of students. Let's say Harry Potter equals student with the first name of Harry, the last name being Potter. Let's create another one. Just going to paste this underneath. This will be Draco Malfoy. The first name will be Draco. Last name will be Malfoy. And let's go ahead and print them out. So we'll say print Harry Potter and print Draco Malfoy. Let's go ahead and run this. So run. And over here in the right, you'll see that we get this very ugly looking statement, which is basically the address and the type of the object. So the first one being Harry, we get student, which is he is of type student. We get the address and also the same address for Draco Malfoy. You can see here they look quite similar, but the addresses towards the end you can see are different. But this representation isn't that clear in Python. Like, what does this mean? It could mean anything. How are we meant to understand that? But what helps is that we can actually add these class functions that will allow us to represent our classes, our objects in a more human readable way. Now, this one is underscore underscore string underscore underscore and then self. And this will return a string representation of our student. So we'll say return, and then we need to format this. So we'll say self.firstname and then self.lastname. Last name. Now, with this in mind, this string here, now it has to be underscore underscore string underscore underscore, just like with init. It has to be written like that. This is going to return a string. Now, if I run this, we get Harry Potter and Draco Malfoy. Okay, so that's like, it makes our objects more human readable. We know what object this is. This is referring to the Harry Potter object, and this is referring to the Draco Malfoy one. Now, let's go ahead and actually enroll these students in. So let's say in Hogwarts. So we have this object. I'm going to get rid of this sports school. Actually, I'm going to comment it out. But now let's go ahead and say Hogwarts dot enroll student, and we'll pass in Harry Potter. Next, we'll say Hogwarts dot enroll student, and we'll pass in Draco Malfoy. Okay, let's run this. Actually, before we run this, let's print out the students afterwards. So Hogwarts dot students. Let's run. And it's saying student, we need students, like so. So run it again. And we're back with our ugly representation. Now, you may be thinking, wait, why is this happening? Given that we've already added our string here, our underscore string to our student, why is it coming out as an ugly kind of format again, this non-readable version of our student? Well, that's because string only does it for those that are read like with ease, so like or individually. So when we did print Harry Potter, it was reading that object on its own. But given that Harry Potter, this object, and Draco Malfoy exist within inside this list, we need something else other than string to do it. Now, to do that, we just need to say inside our student class underscore repr, and then underscore bracket self, and we can literally just go ahead and copy this again, paste it, and now if you run it, we get back Harry Potter and Draco Malfoy. So you also need this represent. It stands for represent, I think, and this is to represent this with inside whatever it's contained in. So as Harry Potter and Draco Malfoy are contained inside this students list, we need the represent class function. Okay, so I think they're actually known as magical functions, something like that. No pun intended, given that we're making Hogwarts classes and students. But yeah, that's our student. Now, a school doesn't just have students, it also has teachers. So we can actually go ahead and create another class called teacher. So say class teacher. And we can copy this over as it's the exact same thing. Paste it. A teacher has a first name, a last name, and we have this string and representative magical methods. Now, this is where a concept called inheritance comes into play. So as you can see with both our student and our teacher, we have the exact same kind of functionality for both. So why do we have to repeat ourselves? In programming, repeating yourself is never good. It's always a red flag. So what can we do to avoid that? Well, let's go ahead and create a more abstracted version of both student and teacher. We'll call this person. And let's paste all of that inside of person again. So I've just pasted everything that we have in student and teacher inside this person class. Okay, now we have 3 classes with the exact same properties. That doesn't really help. Where am I going with this? Okay, so inheritance basically means that this student can inherit from this person. So we can remove all of this inside student. And for now, we'll just put pass. And then next to this student name, we'll put person. And the same we can do for teacher. So we can get rid of that. Put pass. Oops. And this will also inherit, the keyword being inherit, from person. So what does that mean? This means that everything that's inside person will also be included inside of our student. The same also goes for teacher. So we can actually still run this and we'll get the same response as before. So we get Harry Potter, Draco Malfoy. We can, as they're represented here. And we can actually create some teachers. So let's create, I'm just going to add a comment here saying students. Below that, actually, let me just say here, teachers. Let's add some teachers. Let's create our first one. This can be, say, Snape. Say Snape equals teacher. Say first name is Severus. Last name is Snape. Let's create another one. We'll say Slughorn equals teacher. First name equals Horace. Last name is Slughorn. And okay, so now what we can do is let's actually print out the different types. So we have print type Harry Potter and print type Snape. So if I run this now, so over here on the right side of the console, we see for Harry Potter we get student and for Snape we get teacher. Now, for readability wise, I mean, this helps a lot. So we know that one type is of a student, another is a teacher. In terms of our program right now, that's not that useful. However, what we can do is if we go into our school class, now when we enroll a student, right now we can pass in anything. So we can actually enroll Snape into it if we wanted to, but that wouldn't make any sense domain-wise as a teacher isn't enrolled onto a course, a teacher teaches a course. So inside this, we can say that if the student is not of a type student, then we'll raise an error. So to do that, we can just say if not, and the function here is instance, and we'll say student of type student, then we can raise an error. So we can say type error. And this is just, if you're unfamiliar with this, then all we're saying is report back an error. And this is a type error because, you know, student is not of type student in this case. And we'll say can only enroll a type student. Otherwise, it will just append it to our list. Okay, so I'm assuming as well that you've heard of the concept or come across the concept of errors or exceptions. And this raise here is saying that, okay, if whatever we pass here, if it's, let's say, for example, it's Snape, then it will check, is Snape of type student? It's not, it's of type teacher. Then it will raise an error. Otherwise, it will just add the student into our list of students. Let's actually try it out. So let's say down here, we'll say Hogwarts, enroll student, and we'll pass in Snape. Let's get rid of these two lines. And let's run this. So we should actually expect an error message of can only enroll a type student. Let's run, and we get exactly that. You see here in line 61, which is this here, enroll student Snape. Then it goes back to this here. It's saying type error can only enroll a type student. Okay, that's nice. It's making more sense. So we're restricting this enroll student to only allow objects of type student. So let's just get rid of that. Now, both student and teacher, they work exactly the same. So we could actually just use person, but let's add a bit more kind of depth to our student class. Now, to do that, it's still going to inherit from person. So we'll say init like so. Self, we also need first name, last name. But let's say we have also the a student ID. So every time a student enrolls, they have an ID. And for our student, that will be the case. For a teacher, they won't have a student ID. Now for that, we'll say to use this, we need to call this person again. So we need to say super, and that's referring to the kind of parent or the class it's inheriting from. So this person from person dot init underscore init, pass in the first name and last name just as usual. So we're kind of doing it manually here. And then we will set the attribute self.student underscore ID to student ID. Okay, so what's going on here? This looks rather weird. So what does this super underscore init actually, what is it actually doing? Now, our student is inheriting from this person class. This person class has this init with it, so it assigns whatever we pass as first name to first name attribute, last name to last name attribute. It doesn't hold the concept of a student ID. So what we're doing is inside our student class in the init method, we're saying call the class person init, set the first name and last name, and then after that, let's create a new attribute called student ID and add student ID to it. So student ID actually doesn't exist inside teacher. So if we go ahead now and print snape.student underscore ID, we should get an error. Actually, before that, we need to add student ID to both Harry Potter and Malfoy. So student ID equals, we'll give it a string like that. And then for Malfoy, we'll say student ID equals, give it some other numbers. And let's run this. And we get this error here. Teacher has no attribute student ID. So even if we went to this here, so when we created our Snape object and we said student underscore ID, we add something, oops, like that. If we run it, we see now here that init got an unexpected argument student ID because student ID does not exist for our class teacher. It only exists for our student. Okay, so let's get rid of that. So we have now a student and teacher that inherit from this class person. However, with our student, we also have this extra attribute, which is student ID. You can add whatever else you want to it, like age or date of birth, if you want to be creative with it. But I'm going to leave it at that for now. So we have that. And the next thing we want to fill in is our course or courses. So what do we put in for course? Right now, we're just doing a string. So let's go ahead and create a new class. And we'll call this class course. This will not inherit from person because in real world objects, a course is not a person, a teacher is a person, and a student is a person, but a course is not. So we can leave it as a basic class. And for that, let's go ahead and create an init. So we'll say init like so. The course will have a title. It will need a teacher, and course also carries credits. So we'll say self.title equals title, self.teacher equals teacher, self.credits equals credits. Okay, let's add some string representation for it as well. We'll say self, and this will return, we'll add some information, so format string. We'll say self.title, and then we'll say dash, and then we can just add in the teacher, self.teacher. Then we'll say the representative of that, self, and we can just copy in what we wrote for string. Okay. So again, like we did with when we enrolled a student, where we check to see if the student is of type student, We can do the same here as well with teacher. So first we can go ahead and say if the is instance of teacher and then teacher, or if the teacher that we pass in as the argument is not of type teacher, then let's raise a type error and cannot, or we'll have a similar message, can only be of type teacher. So for example, if we try to set Harry Potter as the teacher for a course, we'll get an error as it's of type student, not of type teacher. However, Snape would work perfectly fine. Now let's go ahead and try it out. So let's say down here, let's say courses. Our first one is going to be, say, potions equals course. We'll say first name. Oh, sorry, not first name. We need title is going to be potions. Say teacher is going to be Slughorn. And credits, we'll set that to, say, 100. And let's add another one. Let's say historic magical history. And this is of course. Title equals magical history. The teacher is going to be Snape, although he didn't actually teach that. And then credits, let's say the credits here are 80. Okay, so let's actually run this. We need to run an install. And we get an error. So student ID, we need to get rid of the student ID for our teacher, Snape. Let's run this again. And we get back nothing because we don't have anything there. But let's go ahead and print out potions. We should get something nice as we have a string representation for it and magical history. Let's run this. We get potions, Horace Slughorn, and magical history, Severus Snape. Okay, so now we have our courses. We have a course class. Let's go ahead and actually add that course to our school. So we can, of course, check to see if that is of type course. So let's actually do that. Let's say if not is instance and then course and then capital course, so the class, raise type error. And we'll say can only add of type course. Okay, so let's go ahead and do that. So with our Hogwarts class here, we'll say Hogwarts dot add course. We'll pass in potions, and then Hogwarts add course. We'll add in magical history. Now let's go ahead and add some nice prints. So we'll say Hogwarts courses, and we'll say Hogwarts dot courses. Let's do Hogwarts. Hogwarts students, and then we'll say Hogwarts dot students. Let's go ahead and run this now. And let me just expand this a bit. So we get Hogwarts courses, we get potions with Horace Slughorn, magical history with Severus Snape, Hogwarts students, Harry Potter, and Draco Malfoy. Okay, that's looking good. However, when we don't know with Hogwarts, we don't know who the teachers are. The teachers are stored inside our courses. However, they're not directly stored inside of our class school. Now, we can, of course, add a list for that. However, we We can also infer it based on the courses that we add. Now, to do that, let's go ahead and create a much more kind of useful, another kind of function or method, and this will be teachers. So we'll say get underscore teachers self, and what this will do is first we'll say teachers equals set, because right now we can allow a teacher to teach more than one course, so we want uniqueness. And then for course in self dot courses, here we can say that teachers dot add, and we will add in course dot teacher. So that course dot teacher is looking inside the object course, whichever it's at in that loop, and then it's accessing the teacher that's there. And then finally, we can just return teachers. Okay, so now if we go down, we can do something like print Hogwarts teachers, and this will be Hogwarts dot teacher get teachers, or get teacher. It should be teachers. Let's quickly rename that. Get teachers. Down below, get teachers. Run, and we get Horace Slughorn and Severus Snape. Okay, so that's nice. We have this get teachers. However, what if we wanted to represent this get teachers the same way we do with self.students or self.courses? Well, we can do that. We can, of course, just rename this to something like teachers. And then we can change that here as well. But we still need this like brackets. How do we remove that? And one way to do that is you can add it as a property. So above teachers, you could say property. And as a result, we no longer need the brackets here. And we can actually just run it again. And we get back the same output. However, this time we're doing Hogwarts.teachers. And this is what this property allows us to do. And properties have to be very basic by default, and you cannot accept any argument apart from self there. So like, for example, a role student could never be a property, as you know, we have to pass in a student, and also it doesn't return anything, so it would be pretty pointless at that point. Okay, so that's actually a property, and we have our teachers, our students, our courses. What else can we do? Well, a school also has some form of eligibility, so a school will accept those 12 or over and less than the age of like 18. So we can do something like that. Now, we can add this as a class method, and you'll see what a class method is in a second. So first, write in at and then class method, like so. And then we'll do a function like can enroll. And instead of self, we put CLS. For class method, you always put CLS. The argument here will be a student, so we want to check if a student can enroll into a school. Now, the thing is, with student right now, we don't have an age, so we can actually add that. We can say here in our student class, we'll say age, and self.age equals age. So in the student class, I've just added this extra attribute here and passed age in as an argument. And then down below, let's actually just shrink this. So for Harry Potter, we'll say the age is, let's say, 13. Draco Malfoy, we'll say, in this universe, let's say Draco Malfoy is a lot older, and we'll say he's 25 years old. Okay, so what we can do is inside class method, we can say if student dot age is greater than, let's say, 12, or let's say 11, and student dot age is less than 19, we can return true, otherwise return false. And you're probably looking at me and thinking we could just return this entire condition here. This is just for readability. Let's not get too fancy, but yeah, let's just leave it at that. So this is our can enroll. It's as a class method, but how do we call a class method? What is so special about a class method? Now, a class method is something that is not object specific, so we don't need to call it on Hogwarts. We can call it on school itself. So by that, I mean, let's go down here. Let's print and then do Hogwarts. Oh, sorry, not Hogwarts, school. So the class itself. And then we can say can enroll. So we're not calling on Hogwarts or on like sports school that we created and commented out earlier. We're calling it on the class itself, hence the name class method. Now here we can say can enroll and we'll pass in Harry Potter. And we'll also pass in Draco Malfoy. So school dot can enroll Draco Malfoy. Okay, so let's try out this class method. Let's print it. Let's run it. And we get true. Actually, let's just add. So true being Harry Potter and false being Draco Malfoy. Okay, so that's what a class method is. It's something that you can call on the class itself, and you don't have to call it on an object. It's useful for, I don't know, if you created a class for maths operations. You may not want to create, I don't know, a math object when you want to do addition, something like that. But this is an example for our school. Now, the last thing I want to show you is I just want to expand a bit further on magical functions, magical methods that you can write on a class. So we already kind of did that with this string and repr, but let's add something else to our course. So we have this notion of credits. So every course carries some credits. And let's say we want to do a comparison like, we'll say that potions less than magical history. And this is just a string. And then here we'll just say potions and then less than magical history. So let's run this. And we actually get this error. So we get this thing here. Say that the type error less than is not supported between instances of course and course. So how do we do that? And in this case, I just want to compare the credits that come with potions versus the credits that comes with magical history. So for that, all you have to do is inside our class course, we can add this and say underscore underscore less than underscore underscore and then self. And what we'll do here is just say return self dot credits. And then we also need the one that we're comparing to. So we'll say other course and we'll do other course dot credits like so. Okay, so now if we run this, we get potions. Is potions less than magical history? We get false here, which is true because potions carries credits of 100 and magical history carries credits of 80. And that's what we're comparing in our less than, which is done right there. So this self.credits in our case is first referring to potions. So is potions.credits less than the other course being a magical history, and then the credits on that, is it less than that, and it returns it. So yeah, we can also, because we have our less than, we can also do something like is potions greater than magical history, and here we can say greater than. We can run it and we get true. Because we have the less than, Python can from that infer what greater than will be. However, if you want to explicitly type that, you can say underscore underscore greater than like that, and then self, and then other course, etc. But that's really it for the basics or the introduction to classes. We've covered quite a lot, and if you're feeling overwhelmed by this, fear not, like that is totally expected to kind of look at this and think, whoa, there was a lot of concepts covered here. You know, we created a class, we created like an init, then there's this self thing, and we have class method, property, we have something called inheritance. Do not worry about that. This is something that will just come with practice. Come up with your own concepts or expand on what we've just written here. But you can tell from what we started off with this dictionary representation of a school or Hogwarts, we have a much more richer or enriched form of data with this, with creating classes and having these methods like add course and enroll student. And yeah, all of this much more heavily defined objects taken from real life. But yeah, do not worry if you feel overwhelmed by this. All it takes is more and more practice. You become used to it. Write different versions of this. So you could do something with animals or cars. Actually, to be honest, let's go ahead and actually write down other ideas. So you can do something with cars, just in case you want a reference point later on, with cars such as like sports cars. What other cars do we have? We have Formula 1 cars, etc. So you could do some inheritance there. You could also do one with animals, such as mammals, fish, and what else do we have? Reptiles. Yeah, there's all sorts, even like a company with, rather than a school, you could do something with a company where we have employees, investors, etc. I don't want to spend too long on this list, but yeah, just to give you some ideas on what you can experiment with. Yeah, feel free to try out those or go on something of your own, or expand on this. But yeah, do not worry if you feel overwhelmed. I hope you took some value from this. If you want to go over some stuff again, feel free to just, rewind and look back. All of this code will be made available to you as well on the Replit link, so feel free to check that out. Otherwise, I hope to see you in a future video. If you want to stop by and say hi, there is a Discord link in the description as well. Otherwise, yeah, please like and subscribe. I'm also on Twitter, which can be found in my banner on my YouTube channel page. But otherwise, yeah, have a great rest of the day. Stay healthy, stay safe, and I hope to see you in the next video.